The Army taught me a lot of things that I still use to this day. The concept of selfless service is really reinforced in the Army. First things they really teach is if you take care of your people, they'll take care of you. The wheelchair was not in the plans. Not for me and probably not for the Army, I'm sure. I've been involved in sports, for actually running for pretty much as long as I can remember. Well, I wanted to continue to do that even after I was injured. So I talked some of my friends on the wheelchair basketball team to do some races. I saw the wheelchairs that people were using, and I thought we could do a much better job than that. And then as I was going through college, well, one, I was also racing, so I was constantly building better racing wheelchairs. It was the conversation I had with Stephen Horvath, who was my primary advisor. Basically called me in his office one day and asked me what I wanted to do when I graduated. And he said, you're a brilliant engineer. You understand people with disabilities needs, and they need you. And if you don't go into this field, why should anybody else? And you can make a real difference if you do this.
HERL is a multidisciplinary team full of people from all sorts of different backgrounds, trying to create assistive technology for people with disabilities.
The other basic premise of HERL is that it's driven by solving real problems. And we've solved some, addressed some very tenacious problems, and it takes tenacity to solve them. And it takes teamwork, and it takes time, and it takes effort. But the reward is improving people's lives. And you realize that all of them have friends and family and loved ones, and it impacts them too. What both inventions have in common is freedom. Really, freedom from pain and freedom of mobility.
I have been ever so grateful for the little things that he does for you to make sure that you succeed in life. He's done so much for other people that he doesn't talk about.
If I go back to the Army, I'm sort of driven by the selfless service and making an impact on others' lives. Yeah, I've been very fortunate to be surrounded by great colleagues, great students, and I have had for a long time. And that makes me optimistic. They're changing people's lives. That's really, in the bottom line, that's what we're trying to do. The Army taught me a lot of things that I still use to this day. The concept of selfless service is really reinforced in the Army. First things they really teach you is if you take care of your people, they'll take care of you. The wheelchair was not in the plans. Not for me and probably not for the Army, I'm sure. I've been involved in sports, for actually running for pretty much as long as I can remember. But I wanted to continue to do that even after I was injured. So I talked some of my friends on the wheelchair basketball team to do some races. I saw the wheelchairs that people were using and I thought we could do a much better job than that. And then as I was going through college, one, I was also racing, so I was constantly building better racing wheelchairs. It was the conversation I had with Stephen Horvath, who was my primary advisor. Basically called me in his office one day and asked me what I wanted to do when I graduated. And he said, you're a brilliant engineer. You understand people with disabilities needs, and they need you. And if you don't go into this field, why should anybody else? And you can make a real difference if you do this.
HERL is a multidisciplinary team full of people from all sorts of different backgrounds, trying to create assistive technology for people with disabilities.
The other basic premise of HERL is that it's driven by solving real problems. And we've solved some, addressed some very tenacious problems, and it takes tenacity to solve them. And it takes teamwork, and it takes time, and it takes effort. But the reward is improving people's lives. And you realize that all of them have friends and family and loved ones, and it impacts them too. What both inventions have in common is freedom. Really, freedom from pain and freedom of mobility.
I have been ever so grateful for the little things that he does for you to make sure that you succeed in life. He's done so much for other people that he doesn't talk about.
If I go back to the Army, I'm sort of driven by the selfless service and making an impact on others' lives. Yeah, I've been very fortunate to be surrounded by great colleagues, great students, and I have had for a long time. And that makes me optimistic. They're changing people's lives. That's really, in the bottom line, that's what we're trying to do.
Thank you to UNIMAP Vice Chancellor Prof. Zaliman Sauli and Deputy Vice Chancellor of Research and Innovation Prof. Rizal Fandi, their respective officers and broadcast control team here for hosting this event, as we have done for the past 13 sessions. And a very good evening to our distinguished presenter, Prof. Rory A. Cooper. Before we hear him, please allow me to describe a bit about Dr. Cooper. Prof. Cooper is Distinguished Professor, Assistant Vice Chancellor for Research for STEM Health Sciences Collaborations, Founding Director of Human Engineering Research Laboratories, HERL, School of Health and Rehabilitation Sciences, University of Pittsburgh, United States of America. Prof. Cooper is the Founding Director and Veterans Affairs Senior Research Career Scientist of the Human Engineering Research Laboratories, Veterans Affairs Rehabilitation R&D Center of Excellence in partnership with Pittsburgh. Prof. Cooper has authored or co-authored over 300 peer-reviewed journal of publications and has more than 20 patents awarded or pending. He is author of 2 great books, namely Rehabilitation Engineering Applied to Mobility and Manipulation and Wheelchair Selection and Configuration, as well as being co-editor of An Introduction to Rehabilitation Engineering, Warrior Transition Leader, Medical Rehabilitation Handbook, and the award-winning book, Care of the Combat Amputee. Prof. Cooper is an elected fellow of the National Academy of Inventors, as well as Rehabilitation Engineering and Assistive Technology Society of North America, RESNA, IEEE, American Institute for Medical and Biological Engineering, AIMBE, and BMES. Amongst his belt of awards, he has the 2022 Biomedical Engineering Award, the U.S. Patent Office's Inventor Collectible Card Series, Samuel J. Heyman Service to America, Science and Environment, Service to America, Science and Environment, the National Inventors Hall of Fame, and most recently, the National Medal of Technology and Innovation from the U.S. Patent and Trademark Office, which was awarded by President Biden. Prof. Cooper will talk about forging a new future participatory action design and engineering technologies with people with disabilities. Prof, the Zoom is all yours now. We'll take questions at the end of your talk.
Great. Thank you very much for that kind introduction. I look forward to speaking with all of you and to hopefully your questions at the end of my talk. Yeah. Well, good evening, everyone. I'm going to start by showing you a brief video of about our labs in Pittsburgh. You're welcome to come and visit if you are ever in the area. In the United States alone, 1 in 7 people that has a disability of some kind that impairs their activities of daily living. And technology has tremendous potential for improving the lives of people with disabilities. I was serving in the Army as a sergeant in Europe when I was injured, and I came home with a spinal cord injury and had to use a wheelchair. There was like an 80-pound behemoth that I could hardly get in the car. I realized that there were a tremendous need for improving technology, improving the environment, and improving perceptions of people with disabilities. When the opportunity arose to work with the University of Pittsburgh and the VA Pittsburgh healthcare system, it was natural that we'd start HERL.
The laboratory, our mission is to improve the quality of life for people with disabilities through advanced research or engineering, get people more integrated into the community and to make them more independent. We do this through some of our programs that we have here, whether it's educational or research or outreach.
We started out as a wheelchair lab doing sort of manual wheelchair work and have expanded over the years to include brain-computer interfaces, robotics, virtual reality, cognitive
Recording in progress.
aids, home modifications, and training.
The system that you see behind me, that's called the CAREN system, or the computer-assisted rehab environment. We work with people who have gotten prosthetic limbs. So in terms of how are they adapting to a newer technology. One of the latest technologies that's come out from University of Pittsburgh is the brain-computer interface, a robotic arm directly getting signals from the brain. So we're trying to see if we can get that technology, use it to drive wheelchairs much more efficiently, not just control left or right.
We have a machine shop where we can basically fabricate anything mechanically or electronically that we wish. What's kind of unique is not too many university programs allow you to do the design, but also do the fabrication and take you through all of those steps.
This is our robotics lab. Everything you see here has something to do with robotics.
We developed this called a Strong Arm, which is a robotic-assisted transfer device. This mounts to the wheelchair, folds up behind them.
We've developed ones mainly to replace upper extremity function for people, and then we're working on ones that can actually lift the person.
I think 10 years down the line will be something you would see used quite frequently and have tremendous impact on people's lives.
I was in the United States Marine Corps for 15 years. I was medically retired after being injured in Iraq.
Many of our people in HERL are themselves veterans, and many of them work clinically in the VA.
Press that bottom button so that says set.
I ended up here through an internship program called Elevate, and this program was designed for people to transition from the military back into academics who have any type of interest in assistive technology, engineering, and research.
Since our inception, we wanted to include veterans with disabilities in HERL as employees, as trainees, to reach out to them.
The experience I had transitioning through the programs here and the work that we do here really put a passion and fire inside of me to give back to the community, not only the veteran community, but others with disabilities like myself.
Research is continuously evolving as we can adopt new technologies and information from other fields of science that have influenced us. The end goal for us is full autonomy and full participation in society as equal partners and respect for people with disabilities. So I think we have a lifetime's worth of work ahead of us.
We thought from day one, we're not doing anything for charity. We're helping people to be themselves so that they can do better. You're not taking care of people, you're helping people take care of themselves.
I hope you enjoyed that video. Let me get into some of my other research that we're currently doing. I think I'll skip that slide. Part of our belief is on the National Council on Disability, that the disability community knows better than anybody else about how to be involved in day-to-day planning of accessible products and research and development. And we firmly believe that. And one of the things that we've been trying to do, I think we've been successful at, is training people with disabilities to become scientists and engineers and healthcare providers. We use a participatory action design and engineering process, or the PAVE process, which includes such tools as focus groups, journey mapping, storyboards, expert opinion, user testing, and user acceptance. We do this, we involve or engage users throughout the spectrum of our research, all the way from user need identification into hopefully dissemination and becoming a best practice or even evidence-based policy. We are fortunate that we have a test laboratory so we can work on regulatory compliance, and we have experts in insurance coverage as well. And we're fortunate that we work locally with our insurance system. As part of that, some of our 5 priority areas from a technology perspective are advanced wheelchair design, smart device applications, human-machine interfaces, assistive robots and intelligent systems. And these are all identified by consumers, which in itself shows you how connected, how wise, and how knowledgeable consumers are about research area focus that affect them. And then they're also areas that they very engaged in supporting a participatory action design and research, including universal design, policy and practice and cost, improving education, developing standards and reliability, and knowledge translation. And you can see underneath each of the bubbles some different specific technologies that people felt that were needed. And then in these pictures, you can see some illustrations of things that we've been working on. Recently, we conducted a meta-analysis and published this meta-analysis. And it sort of showed 4 large domain areas, and that's living in the community, travel and leisure, health and well-being, and education and employment. Again, all centered or circled around this participatory action design and research. And some of our sort of core function areas are voice of the consumer and process, creative learning environment, product innovation environment, and leadership and standards. You can see the specific technology domains are a little bit different than what we had learned from consumers through a meta-analysis. This is a global meta-analysis. That might shape it as well. And that's caused us to refocus our research a little bit. So let me go into some of the different domains that we're working in.
Recording stopped.
These
Recording in progress.
So we are fortunate to have a standards, an AT standards test laboratory. We can do both non-destructive and destructive testing. And we test robots, prosthetic limbs, transfer aids, and wheelchairs. And this is just some of the results on wheelchair quality. The machines are illustrated on the left-hand side. Upper left is the curb drop machine. It lifts wheelchairs and drops them. And then the picture below that, in the middle, center left, is a impact testing machine where there's a pendulum that is used to test footrest and casters and other components. And then on the bottom left is a device that uses to test armrests and seats and other components. Then sort of the center upper left is a machine that tests that we call, this is a multi-drum tester, which tests the fatigue life over miles. And that's resulted in such products as the glide caster or the oblique angle suspension caster fork, and commonly commercially sold as the glide, which offers a suspension element I'm highlighting with my arrow here. It's been optimized to reduce the road foot loads and functions. Some of the common failures, this is, shows you a heat affected zone weld failure, which tends to happen between the weld of the seat and the backrest or the cross brace. A little bit that's disturbing is this, we look at the Meyer-Kaplan survival curve, cumulative survival analysis in the bottom. There's this solid vertical line. That's the international standard for combined cycles of the double drum and the curb drop. So that would be the double drum and the curb drop test. And there are a fair number of chairs that are sold globally on the market that that actually don't meet that standard. And the common sort of aluminum ultralight frames, typically the folding frames, they tend to do the best, probably because they're sold widely and there's a lot of knowledge about their failure mechanisms. In some of the other chairs that are, the hospital type chairs and lightweight chairs are typically not used for individual use. They're more for fleet use. And titanium is still not well understood by wheelchair manufacturers, at least the fabrication techniques. We've also worked on the smart wheel. The smart wheel is this device in the upper left that measures how the forces are applied to the push rim. The push rim being the metal ring here that's used to propel the wheelchair. And through that, we found how there's relationships between bicep tendon in the rotator cuff, which you can see here. This is the bicep tendon through an ultrasound image. We looked at the thickness as well as evidence of any tears and then edema or swelling. We did this through working on developing high frequency ultrasound heads all the way back in the 1990s with Philips, and then even working on little marker systems. We could register you can see the marker on the skin. It shows up in the ultrasound images, these two bright lines. that allows us to register the ultrasounds and do them pre and post activity. And we've done it pre and post strenuous activity. This is the the median nerve and the carpal canal and the wrist. You can see the flattening of the carpal canal here, which is an indication of carpal tunnel syndrome. These are the curves you from wheelchair propulsion. The blue line represents the speed. The red represent the propulsive force or the moment about the axle. We did this full disclosure to help our athletes compete in the Paralympics in 2021, and it did help succeed in them earning some gold medals. It also has resulted in multiple products. The Path Lock, which is a device that helps lock the casters, so you can use the chair as a one-arm drive, or a person can reduce the forces required when on a cross slope, so like going down a long sidewalk. And then we have two ergonomic push rims. We sort of were the leaders in developing the ergonomics of both wheelchair propulsion and push rims, and that led to the product, the Natural Fit and the Surge. Now those, since those patents have expired, there's a whole series of ergonomic push rims that have come on the market worldwide, which I think goes to show that we were on the right track there. What's most impressive is it's reduced the incidence of carpal tunnel syndrome among ultralight wheelchair users from about 80% down to about 20%. Carpal tunnel rotator cuff injuries probably can't be reduced too much more than that through wheelchair use, but it can be reduced. Globally, can be reduced by expanding this knowledge in the application of this knowledge globally. But in the United States and in other countries, high income countries, we need to, we've all started to focus on transfers. Another common problem that wheelchair users face is shock and vibration exposure, which can relate to back and neck pain, and sometimes some abdominal injuries. So we've been, specifically Dr. Kuntz in our laboratory has been studying suspension wheels and the impact of those on shock and vibration reduction. So far, there's not much of an impact on whole body vibration, but there is impact of these wheels on reducing shock when going off of curbs or larger obstacles. In the United States and in Europe, it's become more popular now to provide hand cycles. In a lot of other countries, there are sort of upright tricycles as well. This has resulted in ergonomic related injuries among hand cycle users. So we worked with collaborators in Europe to develop an adjustable ergonomic hand cycle pedal. And we can change the grip to customize. It's just a 3D printed grip to a little pommel on the bottom, so the hand fits comfortably. You can see on the right hand side of the image. And then to make sure that the shoulder stays in a neutral position as you're propelling the hand cycle. Nice about hand cycling over wheelchair propulsion is it's more you get pushing and pulling, so it's you know, just strengthen, you get more muscle balance between the anterior and posterior muscles, and this can help reduce shoulder injuries due to wheelchair propulsion. As I mentioned, we've been working on transfers. So the TransConnect system is, as you might think, it uses a Microsoft Xbox Connect and some machine learning with a simple graphical user interface to be able to score, and now we're using it to teach transfers remotely. And the advantage of this is that as in most areas of the world, you have fairly limited time to learn how to do proper transfers because you don't have access to a therapist or an expert clinician all the time or every day or for months at a time. And so one of the ways you can achieve this is by using machine learning models with in-home environments. in order to improve pre-systems transfers. We also are very concerned about pressure injuries. Our lab was one of the co-inventors of the very light cushion that's used quite effectively globally as a pressure relieving tool. It's a cushion, basically. It's an foam and air-filled cushion. If the foam doesn't act as a cushion, so much per se, but more as it's an open soft foam that acts as a baffle. But one of the problems is that even though people learn how to do transfer techniques or how to do pressure relieving techniques, they don't necessarily follow them accurately. And so we've been working on that coaching system. So basically sensors under the seat. You could buy simple load cells for bathroom scales and other types of scales that are really inexpensive. And then we use the machine learning to detect the transfer, the pressure relief. So you can see the clustering here, different types of pressure relieving maneuvers. And then send this data to the cloud, use learning algorithms, and then we can feed that data back to the person to teach them to do what we call virtual coaching, to perform pressure reliefs more effectively, more often, and for longer, and also feed this data to their clinicians if they so choose, or even to other user groups. And so we did a series of experiments to identify that people would use their power seat functions, but not necessarily as instructed. The idea with the virtual seating coach was to use the advances in technology, but first onboard computing, later with a smartphone technology, to provide that coaching in real time, contextually aware, all the time available to the user, and to provide that data to the cloud, one, so those algorithms could be improved based on what was learned, as well as share that data with clinicians in order to improve their clinical practice and eventually improve clinical practice guidelines. And ultimately the goal is that we use the technology interacting with the user to help the user get the maximum benefit from the technology they're using. So one of the exciting things about that, we use a little bit of game theory as well, and gave people simple rewards such as smiley faces, like you sometimes see for traffic lights. We're warning as people speeds, so we give them their own feedback, and then also simple things like a blooming flower or a tree with blooms. We've also sort of discovered through this that there are just some people that are based on their behavior or cognitive abilities or just their demands of their life are unable to effectively learn and practice pressure relief maneuvers, puts them at risk for pressure injuries. And so we've been working on cushion technology with the University of Texas Applied Research Institute. So first we developed a sort of an instrumented seat surface. And then we use an air-filled cushion that we can actively control the airflow into the cushion. Here you can see the airlines coming in that are fed by pumps and fans. The picture on the second row on the right shows the pressure across the surface. You see some red spots and yellow spots around the ischial tuberosities. Use the sort of the common algorithms that people use, which is basically offloading those ischial tuberosities. Then you still wind up with some red areas, blue areas around the respiratory, but you've got to offload it when that seat is surface. We then use the redistribution of them over the maximum surface area of the cushion. You can see we get rid of all of the red, and we get no reds and no yellows, and just some blues and greens. And we can do this actively as a person changes position as well. We think we can do this to help reduce the risk of pressure injuries. not everybody gets pressure injuries from their wheelchair, so you have to look at other surfaces as well. And so we did some studies and developed and patented basically a very simple cushion wrap that can go around a person's toilet seat, fit in the console between the car seats, or even be used on an armrest, so you reduce injuries for elbow ulcers. We put it on the footrest as well in order to reduce ulcers on the calf. We actually you had over 500 people use these with very positive feedback and a reduction in their pressure injury experiences, and even help heal some pressure injuries that they had. And so it's a good tool to also train people that they need to be careful of the risk of pressure injuries, not just when seated on the seated surface while sitting on their wheelchair, but when they do other activities or other parts of their body. Well, I switched directions a little bit to now home and community living. Dr. DiStiano, our lab, has been working on community-based organization support. I had a nice grant from the Association, the Administration of Community Living, where we could provide small amounts of funding to these community-based organizations. But this is all connected, basically web-based, and it's an I Am Here ecosystem using an app and various apps for caregivers and attendants. And look, you can see, you can do caregiver intervention support, so you can measure the health. They can do self-assessment. They can get some relaxation techniques, and they goes back to sort of the gaming theory where you give people some simple positive reinforcement when they do things well. And this can help reduce the strain on caregivers and help caregivers to be able to work, to function longer in support of the individuals they assist. I like this picture on the left, and it kind of shows the volume and the quality of products that we can fabricate in our lab, design and fabricate in our lab. One of the challenges people with limited mobility is being able to be weight, and that leads to metabolic disease and other health weight maintenance problems. Weight is also a challenge for upper extremity injury during both wheelchair propulsion and transfers. We're also looking at possibly measuring sleep length and quality. And so what we basically done is we put 4 smart scales under a person's bed. They're wirelessly connected. They connect to the cloud. And then we use some machine learning algorithms to separate multiple people in the bed, and then also to look at the individual's weight. And then we can look at whether a person gets rolled over, or if one person gets up and down out of bed during the night, or how long they sleep. And all of those, I think, can be helped with long-term health consequences. We've also been working on home health technology, home design, smart homes. We had the good fortune of getting a grant to be able to build 2 homes. The red one I'm circling here, and this yellow one. And the interesting cost is we had to keep them within the price range, the sale price range for a normal family home in the United States, and yet be fully accessible and include smart technology.
Even in the kitchen, where something as simple as preparing meals can be a real challenge.
This kitchen is designed for people with Alzheimer's and brain injury.
This is the queuing kitchen, where specially designed computer programs provide cues or step-by-step instructions for cooking things like pasta.
When I click next, the program will give me my first instruction on how do I get started with making pasta.
Take out cooking pot from the lighted cabinet. Take out pasta from the transparent cabinet. Fill the cooking pot with water from the water faucet. Turn the faucet off. Place cooking pot on the stove. turn on the stove.
This program is ideal for someone with cognitive or memory loss problems. But for those who need more help, there's this futuristic device called the Kitchen Bot. The Kitchen Bot can turn a faucet on and off. It can also open cabinets and drawers and operate appliances. It's a sophisticated instrument that moves up, down, and sideways, and can be programmed for a specific or a group of functions.
And it's kind of evolving. They were also looking at caregiver-assisted transfers, which earlier I mentioned about independent transfers, but also many individuals, especially power wheelchair users or older adults, don't have the ability to transfer independently, and so they require the assistance of another person. What we want to do is use something, there's the Connect system as well to measure how to safely transfer people, and then teach caregivers how to do those transfers in a safe and effective in the environment in which they would practice. So, for example, the person's home environment. And then we've also been working on a robotic assisted transfer device, the strong arm, as we call it. You can see one of my colleagues here transferring a dummy. This is a robot that attaches to a person's power wheelchair, and from that, when it could be on the left or the right side of the power wheelchair, and from this, it can you can eliminate the need for lifting. But the nice thing is the robot does come off the power wheelchair, can fit in a suitcase. So if a person's traveling, they can take it with them. It actually tucks behind the wheelchair, stays within the footprint of the wheelchair, so a person could take it to shopping or something like that, where they might need to use the restroom during the day, and so it's it helps in that regard, and then it also takes less space than something like an overhead lift or a motor hose strength lift. We also now very excited about our work on the zero-load transfer device, or powered patient transport system. Here you can see we've roboticized a manual wheelchair in a hospital bed, and extended the standard function of the hospital bed may have, and then added some special power seat functions. This is a sort of a sit and go power wheelchair. We're working on this I'm currently working on chairs with full power seat function, so tilt and recline. This is Jessica. You actually saw her earlier in the video in her power wheelchair. She's a power wheelchair user herself, and she's one of our colleagues. She's a mechanical engineer, and so here Josh, one of our engineers, is transferring with having to do no sling, no lift, minimal assistance, no modification to the home or hospital environment or wherever the person may live. And you could transfer, it's operated by a tablet. Of course, some of the feedback now that we've been able to successfully do this and practice these transfers with multiple people, is that people are asking us, one, as I mentioned, the more complex chairs with complex seating functions, but also to be able to do independent transfers. I'm not quite sure that's a good idea, except maybe in an emergency situation where a caregiver isn't available or doesn't show up, because you could get your blankets or pillows or something sort of caught up in your. Then you can see you can transfer both in and out of the device with minimal effort on the caregiver and essentially no effort on the person being transferred, the part of the person being transferred. It's also nice if you can see this is a transfer in and out of bed in real time. We haven't sped up this video. So it's actually quite fast, quite safe. And what people really like about it, it's very repeatable. And, all the transfers are essentially the same. And if you have multiple caregivers, that's not necessarily the case. So if we go now to look at some more stuff in the community, expanding activity and participation. We've been working at accessible autonomous transportation vehicles and transportation systems. As you're probably aware, the United States is very dependent on motor vehicles for travel. We don't have a necessarily good public transportation system built out. So one of our challenges really is not only public transportation, but also airline travel. People are relatively comfortable with having autonomous vehicles in the future. Hopefully that can lower cost and increase accessibility of transportation for people. What is a little sad, as you can see in this graph from the U.S. Department of Transportation, is that what most people do is just reduce their travel on a day-to-day, or they ask other people for help, or they limit their travel to daytime, or they just give up travel altogether. And those are really all not good outcomes. And so there's about significant pent-up demand, at least in the United States. There are, autonomous vehicles, autonomous components of vehicles are coming out and coming into transportation now. Lane control, adaptive cruise control, automated emergency braking, and smart navigation are already being rolled out in a number of vehicles. And street sign recognition, vehicle-to-vehicle communication, and collision avoidance are all still are being certainly created. Autonomous vehicles, we're working here on the left. We were actually doing some work on a test track on a new docking system. That's going to be a challenge especially for wheelchair users who don't have the ability to do it themselves. They're going to have to secure the wheelchair to secure the passenger restraints or seat belts. There is limited research in this area, and most of it's focused on older adults. As a result, this is one of our structured literature review. We also have done journey mapping, where we've interviewed individuals with disabilities and families and caregivers, and identified those barriers in transportation. And of course, if you're looking at wheeled vehicle transportation, but even this applies to some extent to airplanes, light rail, buses, is ingress and egress to the vehicle. How are you going to get in and out of it? Wheelchair securement. How do you safely secure the wheelchair? Is there going to be assistance available, for example, with packages, luggage, groceries, or making sure things are appropriately positioned? And also, is there going to be a network? Are you going to be able to get from one form of transportation or another? So you might have sort of what we call, the last 1,000 meters of transportation, where you need to might use a motor vehicle, and then you connect to light rail, that you need to connect to rail to get to an airport, those sort of things. There are some interesting things. We did a large voice of the consumer survey of about 1,000 people, and then based on that, we did a cluster analysis. There are two kind of clear clusters that fell out, and one was basically people with physical disabilities versus older adults, and there are some, you can see some obvious differences here. First thing is that older adults, they're kind of open to using all forms of transportation, from full-size buses to smaller buses to vans and minivans and cars and light rail, whereas people with mobility impairments are really more prefer van or minivan and cars. Now they're obviously younger as well, and a large percentage of them were wheelchair users. The interesting thing is income was about the same. Urban, suburban environments were about the same. Very difficult to find people in rural environments, as in the United States, because transportation is such a problem in those environments. A lot of people choose to relocate. One of the fun things we're doing is we're developing as a result of our journey mapping and our surveys and focus groups, we developed a board game. Let's see if I can try something tricky here and show you a little video about that.
People with disabilities face a range of barriers when trying to access transportation, hindering their ability to fully participate in society. Right now, meet disability advocates and engineers who have designed a board game to bring awareness to the issue and help find solutions that can change lives.
Move up 5 spaces.
It might look like fun and games, but this board plays an important role in research. The board game spotlights something experts and advocates know, and people with disabilities live with every day. Barriers to transportation profoundly impact a person's health and quality of life.
About 25% of the U.S. population has some form of disability that impacts their activities of daily living. So it's a large portion of the population. Our goal is to make sure that transportation is inclusive so that all of us can participate in society to the full extent possible with this degree of affordability and spontaneity.
The pitfall.
Currently, unfortunately, a lot of people with disabilities have to plan days and not weeks in advance just for things that a lot of people take for granted.
Dr. Rory Cooper is a world-renowned inventor of adaptive technologies. Here at the Human Engineering Research Laboratories, or HERL, he and his team develop and evaluate technologies, including this board game they designed as a teaching tool.
There is a winner in the game. The person that gets from the starting point to the selected end point is the winner. But the real point of the game is educational, that we could use to help people who are newly acquired a disability, injury or illness, or to train occupational physical therapy students, counseling students, or students studying transportation, or even transportation providers.
Just like in real life, these players encounter challenges as they try to get to work, access healthcare, legal aid, and social services, not to mention attend activities with family and friends, or perform basic tasks of daily living.
We are concerned about the complete trip, from planning the trip to executing the trip to adjusting to any changes that might happen during the trip. So you don't have to, plan weeks in advance just to go to the grocery store.
Barriers could include lack of accessible curbs and sidewalks, crosswalks that don't allot sufficient time for people with mobility issues to safely cross the street, the absence of elevators, scarce parking options, and non-existent or inaccessible signage and wayfinding. Even bad weather could derail a disabled person's transportation plans.
The curb cut is blocked and not accessible. Go back 2 spaces. 1, 2.
Scenarios in the board game reflect these real-life barriers, and they challenge players and researchers to consider solutions.
And that a person can safely and conveniently and affordably and reliably get from one place to another. I think there's a lot of things that people have said that have played the game and come back to us and said, wow, I never thought about that. And some of those include, how do you use multiple modes of transportation? And what can happen at each one of those transitions? Another one very interesting is slopes and hills. So in other words, you can get there, but it's very difficult, or it's going to take a lot of your battery charge to get there.
Rough terrain isn't the only barrier presented by the environment.
There's not public transportation everywhere. If you live in a rural environment or urban environment or or a city environment, because your transportation options are largely limited by the environment you live in as well.
The team at HERL hopes to one day make this game available for the public to play online. But for now, it remains a valuable teaching tool, revealing transportation challenges and driving innovations to resolve them.
For a long time, people have put themselves in a wheelchair for a day and tried to navigate campus or go somewhere. That's a good experience, but it's a fairly narrow experience. And we want to expand that to what other experiences might be like and make it fun and educational.
Oh!
Prof, we missed the entire video.
Oh no!
The screen was static. We heard the voice, but the screen was static.
Oh, that's too bad. Well, I can send you. Well, the link is in the slides, so you can
Okay, all right.
watch at your own.
All right.
At your own leisure.
Yeah.
I try to be a little tricky there, so I
Get news and free.
now I have to figure out how to get back to my slides. Then we're also looking at airline travel, so we can make it easier. This is sort of a wheelchair that's been modified to be able to fit down the aisle, so a person can transfer into the seat. This is me actually flying with it. And then your assistant can bring the chair down to you. We're working in the United States, and there's actually several countries around the world where we're are also working on making airline travel, bathrooms more accessible, ingress, egress onto the plane more accessible, and just making the airport experience more friendly. They should allow more people with disabilities and older adults to fly.
My name is Joshua Zhong. I am a researcher at the Human Engineering Research Labs. My research project is focused on the performance evaluation and the user interface of the assistive robotic manipulators. So the assistive robotic arms is that a robotic arm can be mounted on the wheelchairs, and that can assist wheelchair users or people with a disability to do some daily tasks using the control interface. So the reason we developed the interface is that we have tested with current robotic original interfaces, and a lot of users have difficulty learning those, either memorize the keys or memorize the command or combination of different keystrokes. So the interface we developed kind of reduce those frustration, so they can quickly learn how to control the robot, and they can do the task just within 10 minutes. There was one veteran look at our robot, and he was so excited, and he said he just point to the robot and saying to the caregiver, "That's what I want." So I think the robot would be really helpful for people sitting in a chair and still want to achieve something for their lives.
And this is our MeBot, the mobility enhancement robotic wheelchair. You can see from the graphics on the right, where you can also, the wheels, the left and right wheel work independently, so we can go over uneven surfaces, uneven terrain. Here, this is climbing a 30-centimeter high curb, and this is Dr. Kim, who was one of our former students. He has high level of tetraplegia. You can see, you can have an eye level conversation. You notice he's in the left hand image, he's even let go of the joystick. It remains stable throughout the entire process. And we are working on climbing small number of steps as well, which would allow access to a lot of places that are not currently accessible, that only have either a step to get into the building, or maybe 2 or 3 steps. Let me just show you. So this is, believe it or not, this is one of the #1 reasons people report to emergency unit for power wheelchairs if they tip and fall over. One of the ways that happens is they're going across a sidewalk and somebody blocks it. And so this, we got the same one that you just saw climbing the curb, can also soft level on uneven terrain. This gives you the kind of the example how they stay. Dr. Cagnati stays level throughout, with one wheel on the top and one wheel on the bottom. And this is about a 30 centimeter height differential. And then this is, at these transitions of slopes is commonly where people fall over as well. And so it's just another example of where we can level the person so that problem doesn't occur. If you look at the pictures at the bottom, you can see us doing this in real world environments. We had the good fortune of working with Amazon on developing a robotic workstation for their fulfillment centers, which are in the United States are being taxed at this time of year. And it allows the person who can remain seated, but they can go up and down, left and right, so it can traverse, or and then it can also swivel. And it allows to basically simulate all the motions that are required of a standing person, but doing it in a seated position. What's interesting is it's not only allowed people with disabilities to use the device, but also individuals, just other individuals that work in these fulfillment centers, to have a break and sit down once in a while and still be able to perform the work in a productive manner. And I think, one of our claims to fame is that we developed the algorithms that are used in almost all the power wheelchairs in the world. This is what allows the left and right tuning, the access, the filter algorithms, and braking, acceleration, all of those sorts of things be tuned to individual users, which is greatly expanding independent mobility for power wheelchair users. We're currently exploring alternative power sources. I'm going to show you a video of air. If you look on the lower right, we've been looking at compressed air, specifically for wet environments, for environments like indoor, what people that live in long-term care facilities don't need to travel very far. And then more advanced battery technology. The lithium-ion, lithium polymers are pretty common, but there are new battery technologies that might last longer, also lighter weight, and could potentially be safer, or two technologies in combination with one another, such as batteries and supercapacitors.
And also the rides in the water parks typically just aren't good for someone without balance. So that's just in general, water parks a challenge.
And being in a power wheelchair makes it even more difficult. These wheelchairs run on electricity, and when water comes in contact with them, the results can be shocking. So how do you build a water park that all kids can enjoy? That's the question Gordon Hartman had. He runs the world's first accessible theme park, Morgan's Wonderland in San Antonio.
We had to come up with a wheelchair that would allow for it to get wet and still be able to move about through the use of someone's ability to use a joystick.
That's when he discovered the work of Dr. Rory Cooper at the University of Pittsburgh School of Health and Rehabilitation Sciences. Dr. Cooper is world-renowned for numerous patents and inventions when it comes to wheelchair technology. He's dedicated his life to improving assistive devices for people with disabilities.
I found Dr. Cooper from the first conversation we had on the phone as a person who really wanted to work hard at ensuring that this idea that we had of developing this chair which would truly be revolutionary.
Gordon and I have the same vision. That's a world where everybody can participate together, so that people with and without disabilities are on the same playing field. The idea is that, hey, an air motor with air tanks, if it's feasible, may provide with a much lighter power chair, much more environmentally friendly, that doesn't need to have the batteries replaced.
And from that idea, a new chair, short for pneumatic chair, was born.
The new chair is powered strictly by compressed air. There's no batteries, so that makes it waterproof. We can recharge it in as little as 10 minutes. Unlike current battery wheelchairs that could take up to 8 hours, it could revolutionize the wheelchair industry.
Brandon Davler, a current graduate student at Pitt School of Health and Rehabilitation Sciences, is a researcher studying under Rory Cooper. Their team works out of the Human Engineering Research Laboratories, where they modeled and built the new chair. The chair that makes a challenging trip to the water park, well, fun.
I like to have the freedom to run around.
It was rewarding to see just how he lit up and the enjoyment that he got out of going through the sprinklers and the water.
He wants to be independent. Quite frankly, we let him go for 30 minutes by himself, and that's what he wants.
And Rory thinks children without disabilities who witness this independence will be influenced too.
That's the kind of experience. And then now recently we've been looking at using origami, so folding flat pieces of metal in order to make 3D shapes so we can revolutionize the new design of wheelchairs. You can see here when we take a flat sheet, we divide this 3D structure, we flatten it, nest it, laser cut it, and then bend it and reform a 3D shape. And I can show you a little bit better here. What's really cool is you can then flat pack large numbers of chairs, and I think this might be able to help improve the quality of wheelchairs available in the United States and other high-income countries, but also make good quality chairs available in low-income countries by teaching people to assemble them, and you require really very few complex tools for the assembly process. So you can see you stack here on a pallet, and then this is what a chair looks like after it's been cut out. There's kind of two views of it. Here's a frame when it's been folded together, and over in the far right is the end product, a complete chair, which weighs less than 9 kilograms and looks pretty stylish. We're now expanding that to the sports equipment. We're expanding it to hospital-type wheelchairs, just a whole fleet of different wheelchairs using the same concept. What's really kind of cool about this, it's all parametric design. Each chair can be either cut in a sort of for a fleet or for an individual specific dimensions. Everything's scalable. And then as a matter of fact, you can take a person's dimensions and then choose what type of wheelchair they want, and then have it spit out any type of wheelchair. And it's what really makes it cost effective. It's basically it always starts with the same flat sheet. And you don't need any complex welding or high skilled welding. We can use spot welding. I've actually successfully tried gluing and riveting as well. So there's lots of opportunities for innovation. This is one of my favorite pictures on the right here. These are all current or former students of mine, all with high spinal cord injuries, all successful engineers. And then the other thing we've gotten into, I guess when you get to be a full professor and have some success, is inspiring the next generation. So working on educational materials to help get young people all the way from kindergarten through undergraduate school to think about inventing and becoming an inventor as part of their as a career option. And so we partnered with the National Academy, or the National Adventures Hall of Fame, and the National Mental Society, and the U.S. Patent Office to create various different types of games. And of course, one of the ideas that when you work with artists and other people is they came up with the superhero idea. So if you look on the right, those are all kind of images of my superhero character. alter ego. So thank you very much for the opportunity to speak with you this evening or today. This is my contact information if you wish to get a hold of me. I look forward to answering any questions you might have.
Thank you very much, Professor Cooper. There was a whole rainbow range of things being done there. I would like to, before I open up,
large groups. So
yeah. Before I open up the screen for questions, I would like to kick off. How big a lab space do you have at Pittsburgh?
So currently we have about 27,000 square feet. So I guess that's about 2,700 square meters. We're in the process of going to 35,000 square feet. And to give you an idea, we have about, if you count students, faculty, and staff, we have about 70 of us.
70. Wow, that's a nice number. Would you say that's a what do you call what do you call this, a peak number or a sweet spot, or you would like to increase that further?
So while we increase it every summer when we bring in our interns, it would go to about 100. And then our lab's a little bit like a beehive, but you know, we could go larger if we, we're so fortunate to have a large donor come and contribute or something like that. We're somewhat rate limited by funding. As I'm sure all of you are aware, we're certainly not limited by the number of challenges. They're older adults and people with disabilities have a multitude of challenges that we do not have the time or resources to address. And that's why it requires a global community.
That's my next question, funding. Do you operate by grants, or do you make use of patents, or you have collaborations, or all three?
We use all three.
Okay.
Yeah, we have grants and contracts, we have donations, we have some like continuing education revenue, we have collaborations, we have industry partnerships. To be the size we are, I think you have to use pretty much all the available funding mechanisms.
And okay, and in your early opening, you mentioned this participatory action design, PADE. How much participation is required or needed for a system or product from design to full test?
That's a great question. So one thing I should, might help you is if you saw through the videos, most of the people with disabilities in those videos actually work in our lab. So we have a large percentage of engineers and scientists and clinicians who are themselves are people with disabilities. And that certainly helps because, we are the customers. And then we have cultivated a large group of sort of advisors and people who participate regularly in all aspects of our research locally. And then we have created a registry that we can reach out to people across the United States. And we've done global studies as well, primarily partners in Japan, India, Brazil, various European countries, Korea. And so that also helps us get larger numbers at times as well. In our case, we like to have somebody who's an end user or affected by the technology. It could be a caregiver as well. actively engaged in every meeting. But when we're trying to identify priorities, we want to try to, we use what's called what I call it the area under the impact curve. So it could be a small number of potential end users as long as we have a very large impact on them, or it could be a more modest impact on a larger number of people, a larger population. So the area under the curve, turns out to be similar, but the reason is different. So it allows us to sort of work on things like orphan products, but also where we might look at a high impact, broader market product, or even a universal design type product. Hope you're on mute.
Okay, a bit off tangent here. Do you work with DoD for advanced military stuff and all that?
We work with DoD, but not on military stuff. Our work with DoD is focused on people who become wounded, injured, or ill during their military service. So
strictly for wounded.
Yes.
Okay.
We don't do any. We don't actually. There's two areas we don't do any animal research. We don't do any. Yeah. I mean, all of our focus is on people with disabilities, and that includes our military and veteran population. Are also.
So how does this begin? You begin by approaching a particular problem, or you wait for someone to come in with a specific problem, and then it begins from there?
So we actively go out and seek problems. So through clinical partners, through surveys, through working with disability groups, and then we, of course, you do your due diligence and do your scientific literature search, do your patent search, see if sometimes some projects, some people might think it's a problem. There's actually been there's a good solution. They're just not aware of it. And so we don't really want to repeat things that are already commercially available or where they're well investigated. So in that case, we might just educate the person of what's available. But if there is a legitimate challenge, there a legitimate need, then we basically work as a team of teams. We'll put a team of experts for that particular problem together from within our lab, or we will reach out to collaborators to work with us to bring in additional expertise, and then we will start to work on that problem. Then we'll go back and first thing you want to do is, as Albert Einstein said, if you had an hour to save the world, what would you do? He said, I would say I'd work for 59 minutes I would spend to define the problem, and I would use the last minute to solve it. And essentially, that's the big part of what we do too, is try to get a reasonable, accurately defining what the problem is, so that and that's a common problem in engineering, right? Is you don't you're not communicating well with the end user, and don't have a good definition of the problem. You could spend a lot of work and you're kind of going tangential to where you need to be going. And oftentimes people are a little too polite to correct you until you've gone sort of too far down the path. And so one of the things we want people that are candid and understand we want candid feedback. But the other thing is to make sure that that's why you have to have often frequent communication and communicate in different means. We've learned over the years that you can do like a very good, solid model, and some will look very realistic, and you show it to a person, but they don't necessarily have a good feel for scale or weight, materials, and things like that. And then they can maybe 3D print a model that helps a little bit, and then you might have to do, we do prototypes sometimes in cardboard or other materials like that, just to get people to give it more of the idea of scale and form in a three-dimensional way. And then we realized right up front, we're gonna have to build multiple prototypes, whether it's software or electronics or mechanical hardware. And so that helps too. If your team starts to realize you're just not going to get it right on the first time. And it's kind of a famous, startup business phenomena, right? You wanna fail fast and then keep moving forward. So you're just gonna realize you're gonna fail fast. So you're used to that you learn from failure, and failure is in some ways a communications tool.
Yep. Those are good points. A lot of people fail to understand that engineering is an end product from work with differentiating with respect to science, which is an initial fundamental kind of stuff. That having been said, that science starts off with some far-fetched thought experiment and all that stuff, but engineering is costly, multi times costly thing to achieve because of the product refinement process. Yeah. So how do you manage that?
What do we manage it? You have to have a good team that communicates well within the team. You have to have multidisciplinary expertise in your team. So as an engineer, how I try to explain this to people is, when I was an undergraduate, you learned about how to solve differential equations as a time series problem. And then you learned about transforms, like Laplace transforms and Fourier transforms. So you could take differential calculus and turn it into algebra. That's why if you have like a mechanical engineer, biomedical engineer, electrical engineer, physical therapist, physician, and even a business person all looking at the problem, they're gonna have a different perspective. And then together, hopefully you come up with an effective and come to a quicker, useful problem. And of course, in engineering, you learn too, there's often not one solution. Could be multiple solutions. So what you're trying to find is the best acceptable solution. And now even realizing that after a product comes to market, it can evolve. And so it's kind of a cliche, but you don't want to be perfect to be the enemy of the good. So once you've kind of got, and if in engineering, the other problem is it takes 50% of the effort and the funding to solve the last 5% of the problem.
Right.
So that's just another concept.
That's the killer.
We do have done and continue to do some basic science research because you have to, because if that fundamental technology or that fundamental knowledge is not there, you can't really do the engineering research. You can't do the product development or the engineering part of it. So like I said, with the ultrasound, we had to work on how to develop high frequency ultrasound to be able to acknowledge their peripheral nerves, in order to be able to look at if we could do real-time measurement of carpal tunnel or rotator cuff injuries. So we had to work on those components where, like currently we have some work on fundamental stimulation of vagus nerve, which is really showing the scientific basis of why acupuncture, acupressure works to some extent. And then, we have had to develop technology. We had to do some research in that area. We had to do some technology. So we do have like a physiologist on staff, or a couple of physiologists actually.
So that means your lab, VRL, is specifically concentrating on physical disabilities, not those vision, hearing, and all those stuff.
That's correct. Yeah, we typically focus on mobility and manipulation.
Mobility, okay, right, yeah. Mobility.
Yes, upper extremity, physical disabilities. Sometimes you don't have a choice. You focus on multiple disabilities. So, for example, we have research on environmental sensing for navigation, because that could be related to both mobility and a cognitive function or mobility and visual impairment. And so you have to kind of work that what we call polytrauma, right? Where you have multiple disabilities interacting with one another, or multiple impairments interacting with one another.
So the other thing that comes to mind is how much of your output is it skewed towards veterans only, or there's a spillover to non-veterans civilian usage also?
Oh, well, almost everything is related to civilian usage. I mean, for veterans, it's how the origin of the injury occurred, but an amputation is an amputation, a spinal cord injury is a spinal cord injury, multiple sclerosis is multiple sclerosis, ALS is ALS. So the only real difference it makes in the United States is the balance of the population. So who has those conditions, and then the other part is how our insurance coverage works. So in our case, at least in the American healthcare system, often the veterans, because their health insurance coverage or the way they receive care is different, is more holistic than civilians coverage. If we can get funding if there's a problem that civilians have that veterans also have, if we were to start with the veterans, our likelihood of being able to make that technology available to the civilian population is increased.
Okay. All right, there are some questions here on Zoom. How do you ensure that the assistive technologies you develop are accessible and affordable for a wide range of users?
Great question. So the first thing is, you try to, in your solution set, look for the most appropriate technology, so not necessarily the highest cost. Although I try to caution people not necessarily design for low cost to start with, because that can over-constrain your ability to design something new and creative. And in my own life, I've seen that over the years, right? There were 5 decades of almost no innovation in manual wheelchair design because it was all constrained by cost. And then, of course, and cost is a tricky thing to measure because, so for example, if you measure cost just simply by the cost of the assistive technology, then that's a flawed way of looking at cost. Because there's if you return a person to work, you might want to spend more money on that, right? Like, I'll give you an example in my own university. So when I came to a university, their basically the insurance coverage was basically based on our Medicare, which is our coverage for adults over age 65. And said, logically, as a university or as an employer, that makes no sense because most of the people here are under age 65, and if they have or acquire some sort of impairment that limits their sensory or physical function, we want them to work or continue to work, not go home and stay at home. And so if you constrain yourself to cost in the technology that you provide, you're actually working counterproductive to what you're trying to achieve. And so you have to look at it kind of that's back to this more holistic approach, both from society and from the end user. And then the other little thing you have to be a little cautious on cost is not making assumptions about people's ability or willingness to pay. Now, I understand full well. I've spent a lot of time working in South America and in the Southeast Asia or Southwest Asia, and there are certainly cost constraints. So you'd obviously, like I was talking with the Kirigami wheelchair, where you can flat pack things, you can take advantage of high-tech manufacturing of components, but make the shipping very inexpensive, and then do local assembly. You can, hopefully provide low, affordable, high-quality products to a much larger population. So so you have to look at both things. Like the on-the-move pads are really inexpensive, fairly easy to manufacture technologies that a cost of a pressure injury in the United States is anywhere from $10,000 to $100,000 for a single incident, and a $15 item to help prevent them is pretty inexpensive by comparison.
I keep hearing this, but is kirigami is an actual Japanese word, or?
Yes, it is, believe it or not.
I only heard of origami.
So kirigami and origami are closely related. Origami is the folding of flat sheets into 3D objects, and kirigami is cutting and folding into 3D objects.
Oh, okay. That's
So
new.
kirigami adds the cutting component.
Okay. That's nice. There's one more. Prof, what do you think of open sourcing projects so that more people can use them? This way we can help many people in the process.
It's not a bad idea. We actually just got funded for an open source project on adaptive sports and recreation devices. I haven't had great success with totally open sourcing. I think you need a moderated open source. So just like, if you have a website or Zoom or something, you're the moderator of the session here. I think you want to do the same thing with open sourcing. You need some experts in there to separate the good from the not so good ideas, right? Or the that's the so that one of the things that we're looking to do with our open sourcing is that people present potential solutions or things that have worked for them, but then have actually do engineering testing on them and have experts review them, and then get other users to use them as well, and then kind of put them out there. So, but I think open source is a good way. Open source can be good in two ways. It's good at generating ideas. It's a good brainstorming tool. But like I said, you have to moderate it. And then the other open source, which is interesting, is there are professionals that have excess capacity or have an interest to get engaged. So they may not be in this field, but they're happy to engage, or they might be retired and they still want to be engaged in some way, and that makes perfect sense for open sourcing as well. The challenge is if you go totally open, you can get overwhelmed trying to find the good ideas, sort of finding a needle in a haystack problem.
Okay. Do you use 3D printing technologies in your research? I know most
we make about 7,000 3D printed parts a year.
Pardon?
We make about 70,000 3D printed parts a year.
Oh man. I suppose this is from the whole range of 3D printing, from metal 3D printing to plastics, polymers.
So we don't currently have metal 3D printing. We actually have funding to get a metal 3D printing. That's why we're expanding our space, because you have to have special facilities to do metal 3D printing. I the caveat is when we do all of our 3D printers are commercial production 3D printers. And so, you know, that require one of the keys with 3D printing is controlling the environment.
Yes.
So you get consistent quality in the parts. You know, of course, there's all science to designing with 3D printing and what type of materials you can use. But you know, we have 3D printers that we can make excellent quality parts that people use. So we have SLA, SLS, FDM, and object. So our current 3D printers, and if we talk this time next year, hopefully we'll have metal 3D printing as well. And so that gives us a lot of flexibility in design. And on top of that, we have you know, 3 CNC milling machines, 2 4-axis, 1 5-axis.
Wow.
We have a turning mill, so that's a mill and a lathe together. A CNC machine. We have 2 CNC lathes, and then we have a laser brake for sheet metal bending. I mean, a CNC brake for sheet metal bending. We have a laser cutter, actually 3 laser cutters. So then we have a complete electronic shop as well, so we can do multi-circuit boards.
Do you make your own PCBs?
All the time.
All the time, okay.
Like 10s a week.
Wow. So you have a whole set of electronics designers and
yeah, so we've got mechanical engineers, biomedical engineers, electrical engineers, computer scientists.
Yes, the product is a human centric, so it requires every conceivable field to be involved in.
It does, and we kind of evolved this way because we wanted to. So one of the challenges in assistive technology is that your results are going to be impacted by the quality of the prototype. You know, the better the quality of the prototype, the more useful your results are going to be. And then the other thing that kind of led us down this path was the quantity of the number of people you can enroll in the study. So when I got involved in this, you know, it's common for people to publish studies of 2, 3, 4, 5. You know, 10 was a really big study. You know, unless you have a very rare condition, that's not really a definitive study. And then the other thing is we found out it's kind of related to the quality of the prototype, but the likelihood for technology transfer or even just uptake among users and consumers is related to the quality of the testing, the documentation, and the product you can produce. And so, you know, to sort of lower the valley of death, you know, we did hard to make very high quality products, and then also start from the beginning to make sure that we're meeting all of the regulatory documentation. Otherwise, the company would have to start all over again. And then in our case, because we are a university and a government facility together, we actually are the manufacturer in some cases.
So you do have manufacturing capabilities too.
Yeah, we only manufacture for orphan products.
Oh yeah, all right, understood.
Something that it's not commercially viable.
Not mass manufacturing.
Not mass manufacturing.
Wait, somebody's. How about you have published quite a number of papers, but the research orientation is towards a product. So where do you draw? How do you publish? Where do you draw the line? With scientific publication and product development.
That's a great question. Well, I have over 400 peer-reviewed journal publications, so certainly we do that. And to give you an idea, I have about 40 patents and about 400 peer-reviewed journal publications.
Yeah.
And if you're in academia, that's in the United States, I imagine in most countries in the world, at least when I've been asked to be an outside reviewer for promotion and tenure in other countries, people don't, most academic institutions don't know what to do with patents.
Yep.
And, they look mostly at peer-reviewed publications or monographs, especially engineering, it's primarily peer-reviewed publications. But you can see the relationship for even somebody who's very product-oriented is about 10 to 1. And there's also kind of a misnomer that that if you're interested in device design, I do all of our devices. There's a lot of there's a lot of evaluation and science that goes behind it as well, right? So we do usability studies, we do clinical impact studies, user impact studies as well, large scale survey studies. So yeah, so and then funding agencies, they realize to bring a product to market is usually a pretty long scale, right? When you start from concept to an actual product on the market. So if you don't do publications in between, it's a pretty tough way to demonstrate you're on the right path. So we have to sort of do both, right?
Right.
And the other thing is, I think publication and presentations are important to move the field forward. We have to share with one another.
Yes. Sharing that part is quite crucial there. Yeah. Okay, one more here. What advice would you give to students or researchers interested in pursuing a career in bioengineering, specifically focusing on assistive technology?
Great. Well, first, find a lab doing that kind of work, right? And do an internship, get your degree there, do a postdoc or a fellowship. That's one way to do it. And also, on the way, volunteer, right? Go work with volunteer with a disability-related service organization or advocacy organization. So you learn more about it. If you think about it, I think that's one of the things that we don't do well in engineering that we could do better. If somebody wants to become a physical therapist or a physician, they're usually required to do so many volunteer hours in the healthcare system before they apply or before they're accepted. In biomedical engineering, you probably should do the same thing, right? If you want to do rehab engineering, you probably should go volunteer in a rehab clinic, a rehab center with a community-based organization.
Learn about the problem.
Same thing, frankly, if you're doing medical devices, probably worthwhile to spend some time with, depends on what type of device you're interested, but in radiology or medical imaging or whatever, field, physical medicine, rehab, it could be or surgery. I still do some work in other areas outside of rehab engineering. I didn't really get into those on my talk today, but and you have to. When the bottom line, if you're getting into biomedical engineering, regardless of what part of biomedical engineering, you need to learn how to communicate with and build relationships with the people who are providing the care or the services.
Yep. All right. Thank you, Prof. Cooper, for all those answers. Quite some out of the world. Are there anybody who'd like to ask a question before we bid adieu? Yeah. Nobody asking questions? All right. If that's the case, then Prof, hang on. We'd like everybody to switch on their cameras for a online snapshot. Please, everybody, switch on your cameras, please. Switch on, turn on. Cameras, please. Everybody present in Zoom, please. Thank you. Thank you. Thank you. Come on. A bit more.
Kita kena snapshot.
Snapshot.
Okay,
Please.
we're gonna first picture. Smile, cheese, everyone. Nice, nice, nice. Okay, 1, 2, 3. First picture. Next.
Hey guys, smile. No talking.
Okay, this is the second picture. In 3, 2, 1. Smile, cheese.
Okay. Cheese.
Okay, and lastly.
Last one.
Okay, 1, 2, 3. Smile.
Okay.
Very good. Thank you. Thank you, everyone.
All right. Thank you. Thank you very much. Thank you very much, Prof. Cooper, for the enlightening new field for me. I'm sure a new field for a lot of my colleagues from University of Malaysia, Perlis. A lot of things to be done. A lot of things that have opened our eyes to. I do hope someone would reach out to you and strike out some collaborations, research-wise or otherwise. With that, we thank you. Bid you good night. Thanks for visiting.
Jimmy and I are happy to speak with anybody. We'd love to work.
Yes, thank you, thank you, thank you very much.
Okay, thanks, thank Dr. Cooper. Yeah.
Thank you.
Bye. Yeah.
Okay, for all the others, there is a attendance form linked in the chat. You guys could go and get a chat over there.
Ada share ni tak? Apa QR code?
Dah share dah. Tak, kita share screen je tadi.
Share screen. Bagi tahu kita pada share tapi tak link.
Nanti kena table bagi dia co-host.
Share attendance dalam Zoom webpage.
Oh ni? Oh, kat sini. ISICS Secretariat. Ni, buka dia. Pin. Spotlight. Ada dia slideshow.
Ini pakai apa? Sensor?
Sensor apa?
Mr. Hani Duome.
Oh, dia punya.
Share lah.
Where are you from? Mr. Hani.
Ini pakai nombor.
Ya. Pagi ni dia keluar.
Yang nano satu. Oh ni nano.
Nano sini. Dia 6. Tapi awak dia tak ni. Dia tak tapi ya. Ni kita tak ni. Tapi dia stay yang tu. Dia jadi iklan. Kau nak kena tutup gambar iklan tu. Gambar iklan tu kat mana? Iklan kat atas. Iklan atas ni, iklan ISICS ni. Mana? Yang ni. Tapi kita tak buka dia pun. Dia tutup je ke? Tutup. Tapi kita dah buka dah. Kau nak kena buang studio mode. Kau buat apa tadi? Buat apa pula itu ya? Sekejap. Oh. Oh, dia okey, keluar dah. Jalan keluar. Ini. Hao kita duduk pergi kat sini tapi dia dengar. Dia dengar bunyi kali-kali. Alah, tapi dekat Participatory 14 orang dah pergi. Oh, sebab dia tak mau bagi orang hilang. Tak mau bagi orang habis ni pun sebab pasal kita lawak.
Cik Bani buat macam nak marah saya takut. Kenapa? Sukarelawan tu bukan jalan tak?
Kita nak makan dia.
Oh, bukan dekat tu, dekat Cik Syah salah ni.
Saya salah. Nanti jumpa.
Nasi kubas?
Oh, kita buat anda ni. Kita sekolah. Sejak dulu. End stream. Ada mana?